Interior molecules attracted in all direction do not have higher the intermolecular force, higher is the viscosity. Force is proportional to area as well as the velocity gradient. When velocity gradient is unity and area of contact is unit area, then hello my dear students, welcome back to the last session on the chapter States of Matter, Gases and Liquids. Last class we studied about liquefaction of gases, liquid state we started and we learnt one property, that is boiling point. Today we shall learn about the other properties of liquid state, that is surface tension. So what is surface tension? We shall understand surface tension by taking an example. I shall consider a molecule of a liquid which is inside the liquid. Okay. Now this molecule will experience the force on all direction, isn't it? It is pulled equally and oppositely from all the direction. So interior molecules attracted in all direction do not have any force at all which is acting on them, because whatever is there, it is equal and opposite. From this side it is pulled, on the other side also it is pulled. So it is equal and opposite to one another. So it is attracted in all the directions. Now if I tell, or if I take a molecule on the surface, so I am taking a surface molecule, this molecule will experience the force only on one side, that is, it is from below. The other liquid particles which is there, it is trying to pull this surface molecule. On the other end it is empty and it is not balanced. The force which is there, which is acting on this molecule, it is not a balanced force at all, or the attraction is not balanced at all, isn't it? Thus, surface tension is the force which is acting perpendicular to the line drawn for per unit length of the surface is called as surface tension. So what is surface tension? It is defined as the force acting per unit length perpendicular to the line drawn on the surface of the liquid. So if this is the surface of the liquid and this is the line drawn, the force which is acting perpendicular to the line drawn per unit length of the surface is called as the surface tension. So surface tension is denoted by gamma. It is nothing but force by length. So what is the SI unit? It is Newton per meter. Okay. Now there are two factors on which the surface tension depends on. One is the attractive force. If the attractive force between the particles are more, okay, or the intermolecular force of attraction is more, then the surface tension will be more. That is the first factor. Second factor which it depends on is the temperature. That is, increase in temperature decreases the surface tension. So if I increase the temperature, the surface tension will decrease, whereas the intermolecular force of attraction is stronger, then the surface tension also will be more. Okay, so these are the two factors on which the surface tension depends on. Next we learn about the importance of surface tension. Have you all seen a drop of a water? When you just put water in form of drops from a dropper, you can see it has got a different shape. Why it has got a different shape? The molecules, when it is dropped, it wants to reduce its surface tension, so it will just surface area or the surface energy has to be reduced so that it becomes stable and it will get a molecule will all come together to take up a shape of what you can see of a drop. So it will not flow, water will not just flow as it is like a stream, it will come in the form of drops, and those drops have a particular shape is because of the surface tension. Next what we can see is insects walking on water. Have you all seen some insects can walk on water? Why exactly? Because their weight is lesser than the surface tension. That's why they will not go into the water. They can just walk on water. Their weight of the insect is less than the surface tension. Next is capillary action of water. Water can just move up in the capillary action. Have you all seen that? That is also because of surface tension. Next is concave meniscus of a liquid. If you take a liquid in the beaker or in the test tube, have you all seen it has got a concave meniscus? That is also because of surface tension. Next, polishing edge of glass on melting. Have you all seen glass melting? Melting glass, you can see the edge is always rounded like this. It is not having a different shape. It is having a nice polished edge. That is also because of surface tension. So these are some of the importance, or we can see surface tension in our daily life as well. Okay. Next is the next property, that is about viscosity. What is viscosity? Now if I take three different liquids. For example, I'll just take a plate or a glass and I'll put a drop of water and I'll put a drop of milk and I'll put a drop of honey. And I'll just slant it. Which do you think will flow first? First water will reach the end, milk a little slowly probably, and then you have honey which flows really very slowly, isn't it? Yes, because honey has got high viscosity. So what is viscosity? It is the internal resistance to flow possessed by a liquid is called as viscosity. What is it? It is the internal resistance to flow. They don't want to flow. There is a resistance when they are flowing. That is viscosity. Okay. So, viscosity is due to intermolecular forces. That is, higher the intermolecular force, higher is the viscosity. So, between the molecules, if the intermolecular force of attraction is very high, then the viscosity also will be high. I shall consider there is a drop of a liquid on a surface or any surface where it is flowing. Okay. There is one layer which is there attached to the surface, that is this. There is one more layer which is formed which is just above it, and there is one more layer which is just above it. The layer which is there attached to the surface moves very slowly. Okay. Whereas one layer above it will be a little faster. Okay. And the layer just on the surface of the liquid will move much faster. So if I consider the speed with which it is flowing is u, okay, and the velocity of this, the layer which is on the attached to the surface will be u minus du, it will be a little slower, and one more layer above it will be a little faster, that is u plus du. Okay. And the difference, that is, what is the difference between these two layers? That is dz we will take. Okay, or the distance between the two layers. And A, we will take the area of the plate. So, what is it? U is the velocity of the middle layer. The layer which is there on the surface will move slower. So, du minus du, that is small change in velocity. Du plus du, because it is moving a little faster, it is plus du there, and the distance between the two layers is considered as dz and the area is considered as A. Now, the flow in which there is a regular gradation of velocity from passing from one layer to the next layer is called as laminar flow. Such type of a flow, we call it as laminar flow. There is a gradation, there is a different gradient is there formed, isn't it? The first layer is moving very fast, the second layer is a little slow, and the third layer is very slow. So there is a gradation in the velocity from passing from one layer to the other layer. Hence such flow is called as what? Laminar flow. Okay. Now we are going to derive the mathematical form. How exactly? Now what did we consider? First layer, second layer and the third layer. This is the area layer which is in contact with the surface. So this is u minus du, which moves very slowly. This has a velocity u, this is u plus du. And the distance between them we considered as dz, and the A is the area of contact. Now there is a force which is required for it to flow, isn't it? So we are going to take that force is proportional to area as well as the velocity gradient. What is velocity gradient? Velocity gradient is change. What is the change in velocity? Du. And what is the distance between the two layer? Dz. So du by dz is called as the velocity gradient. Okay. So force is proportional to A, that is area of contact, and force is proportional to du by dz, which is nothing but the velocity gradient. So I can put these two together and write force is proportional to A into du by dz, where A is the area and du by dz is called as the velocity gradient. To remove the proportionality, I will write it as force is equal to eta A du by dz. So what is eta? It is the proportionality constant called as coefficient of viscosity. What is it? It is called as the coefficient of viscosity. Now what is coefficient of viscosity? Or viscosity coefficient is a force when velocity gradient is unity and the area of contact is unit area. That is, force will be equal to, what is this? Viscosity coefficient if area is 1 and du by dz is also 1 and area also is equal to 1. Okay. So when velocity gradient is unity and area of contact is unit area, then viscosity coefficient is equal to the force of acting. Okay. So SI unit of viscosity is 1 Newton second per square meter. Newton second per meter square. Okay. Which can also be written as Pascal second. Okay. What is it? Newton per meter square is called as Pascal. So we can write it as Pascal second, which is 1 kg per meter per second. Okay. So this is the different way of giving the units. Next is, in CGS system, the unit of coefficient of viscosity is Poise, which is named after the scientist Jean-Louis Poiseuille. Okay. Now viscosity depends on temperature, nature of the liquid and the molecular mass. So it depends on the three factors. What is it? It depends on temperature, it depends on the nature of the liquid as well as the molecular mass. Greater the viscosity, more slowly the liquid will flow. Glass is a highly viscous liquid. So if you see the old window panes, no, below there is a thickness because slowly over the years the glass is slowly viscous, it is slowly moving below. Okay. So the bottom portion of the window panes tend to be a little thick. Only I am talking about the old window panes glass which you can see. Okay. So that's about viscosity. So next class I am going to start with a new chapter, that is hydrogen. So I hope you have understood today's class. Thank you my dear children. Stay curious, stay focused. See you next class.